So we're asked to solve and justify steps using the properties of equality. So here we need to do two things. We need to solve the equation, and we also need to justify our steps using the properties of equality. So we have two requirements in order to answer this question. So I'm looking at my first equation here, and it looks like I have um, an equality between two ratios, which means I can use cross multiplication. But I need to be able to justify why exactly I can do that. So instead of using cross multiplication, I'm actually going to just refer to my list and see if there's anything that I can kind of pick out from my list here that will allow me to get this x by itself. So I see that x is being multiplied by 3 and divided by 5. So if I look at my multiplication division of properties of equality, it says that I can multiply or divide both sides of an equation by the same thing and the equation remains equal. So I'm going to use that one. So for this one, I'm going to multiply both sides by 5. So I multiply this side by 5 and this side by 5. Okay, 5 and 5 cancel on the left. And then what I'm left with is 3x on the left, and that's equal to 2 times 5 over 3 on the right, which is 10 over 3. Okay, and my justification is multiplication, property of equality. And we got that right from the list. Okay, so that is what allows me to make that statement. Now I see that x is being multiplied by 3. I know that I can undo multiplication by 3 by dividing by 3. So if I divide this side by 3 and then I divide this side by 3, what I'm left with is x on the left. Okay, I have x on the left, and that's equal to 10 divided by 3 divided by 3. So that is 10 over 9. Okay, and this is going to be my division property of equality. And I got that one straight from my list. What I'll notice that though is that dividing by 3 is the same as multiplying by 1/3. Okay, so that is how we got this answer, by using these two properties and recognizing that when I divide by 3, I'm multiplying by 1/3. Let's look at one more example. Our next example, we have 4z minus 3 minus 1 half equals 1 half. So if I just rewrite this equation to give myself a little more space, 4z divided by 3 minus 1 half is equal to 1 half. Okay, I need to solve this for z. Z is my variable. There it is. What's being done to z? Well, I see that the term involving my variable, 1 half, is being subtracted from that. So I want to get this term by itself. And the way I get this term by itself is I need to somehow get rid of this subtraction by 1 half. And I'm going to use the additive inverse to undo subtraction by 1 half. And how I do that is I add 1 half to both sides of my equation. Okay? So if I have 4z over 3 minus 1 half plus 1 half, on the left that just leaves me with 4z over 3. Minus 1 half plus 1 half is 0. Okay, 4z over 3 plus 0 is just 4z over 3. Alright, now on my right side I have 1 half plus 1 half. Okay, now how do I add these fractions? They already have a common denominator of 2. So that means this is the same thing as 1 plus 1 over 2, which is just 2 over 2. So 4z over 3 equals 2 over 2, which is 2. I'm sorry, 1. 2 divided by 2 is 1. So anything divided by itself gives us 1. All right, now I have 4 times z divided by 3. So if I use my first problem as a reference, I know that I can multiply this side by 3 and divide by 4, and I will get my answer. Also, notice that the the multiplicative inverse of 4 thirds is 3 fourths. So what I'm going to do for this one is I'm going to multiply this side by 3 fourths, which is the reciprocal of 4 thirds. So what I get is 3 cancels with 3, 4 cancels with 4, and I'm just left with z. So if I multiply this side by 3 fourths, I get z by itself. But that means I have to also multiply this right side by 3 fourths. So 3 fourths and 4 thirds cancel, and I'm left with z on the left. And then I have 1 times 3 quarters on the right. And I know that 1 is the multiplicative identity. So if I multiply something by 1, I get that thing right back. So z equals 3 fourths. And I'm going to, what we did to justify this step is we used the multiplicative property of equality. So I'm just going to put multiplicative property of equality.